Well, here's another integral for us to perform. There are in fact three methods we could use here. The first is, we notice this is a nice clean power. I mean, it has a function inside it. And the derivative of x plus 4 is 1, which is what we have imagined out the front at least. So this is exactly in the form in which we can integrate, pardon that, we can get this pattern plus c. That would be the simplest way ahead. The second method would be to substitute. Now, I haven't taught you substitution yet, or at least we haven't revised it, but we could let the x plus 4 be some constant. So let u equal x plus 4. Normally, by the way, we would incorporate this here, but I'm not going to have a great deal of room. Differentiating, du will equal dx, or if you like, du dx will equal 1, and then du equals dx. So this integral will be the same as, in place of x plus 4 we can write u squared, and in place of the dx we can write du. The integral of u squared is u cubed on 3, and substituting back in, because u is worth x plus 4, it's x plus 4 cubed on 3. That's our second method. In a way, what we did here is use the substitution technique or method, but without actually performing the substitution. You can see the result matches quite exactly. Now, the last method I'm not sure that I have room for, but we'll try. And that is, because this particular power is relatively small, it's only a square, we can in fact expand it. So we could write this as the integral of x squared plus 8x plus 16 dx. Of course, if this was a power 21 or even as high as 8 or 9, you certainly wouldn't want to go this way. In fact, these two methods are almost always preferable. And integrating this, we get x cubed on 3 plus 8x squared on 2 plus 16x plus a constant, which I'll call C0, because we're going to change that constant later. We're going to split it into two other constants. 2 will go into the 8 4 times. Now, I'm going to take a common factor of 3 out, even though 1 doesn't appear to exist in these positions, and divide everything by 3, mainly because I want to show you that this is the same as that. So I need a 3 on the bottom. Well, I already have a 3 on the bottom here. This will be x cubed over 3. Now this is 4x squared, and to get 4x squared I need 12x squared over 3. 3 into 12 goes 4. To match up the 16x, I need 48 x's here. 3 into 48 goes 16. Now, to complete this pattern, I'll show you why it works later, I need to take a constant out of this, and I'm going to put a 64 over 3 as my last constant, plus c. And believe it or not, this expansion, x cubed plus 12x squared plus 48x plus 64, is x plus 4 cubed. Now, I showed you this to discourage you from unnecessarily expanding the expression inside integrals. It's sometimes a good and useful method, but sometimes it can lead you into bog you down in a lot of detail that you don't need. particularly when there's an overall pattern that you can either solve by substitution or seeing the pattern outright, that will make your life so much simpler. But there are three methods for solving it. Just before we go, I'll show you that this in fact does expand to this. When we're expanding x plus 4 cubed, we're going to get, we've got just enough room in here, we're going to get x cubed as the first term, then we're going to get an x squared times 4 as the next term, then an x times 4 squared, and then a 4 cubed. That's going to be the pattern. If I write the powers in, you'll see we get an x cubed, then this power drops by 1, this rises by 1, drops again, rises, and so forth. If you remember Pascal's triangle, you remember the coefficients will be 1, 3, 3, 1. And what we get is x cubed, 3 times 4 will be 12x squared, 4 squared is 16, and 3 16s is 48x, and this is 1 times, of course, 4 cubed, and 4 cubed is 64. There it is, here. The same pattern, the same result, which is why I had to take that 64 over 3 out of that original constant to complete this pattern, so we could show it's the same as the previous two results. Now I think you can agree you really don't want to go here. You don't want to do this unless you were quite good at your algebra. You wouldn't have recognised this or even want to do it. So, what do I recommend? If you ever see something to a power and the exact derivative is outside, don't expand. This is a nice way to go either directly or via substitution. I hope that's made sense to you, and I hope you've enjoyed it.